Hi, my name is Adila, and I will be working with my teammates Rudy Fasano and Sai Tiha um, on our stroke prediction presentation. We will be reviewing the factors that lead to stroke. In this project, our team will analyze the factors that may lead to stroke. The predictive factors are gender, age, various diseases, and smoking status. Our team will use RStudio to explore the features and content of the stroke dataset and create data visualizations. Our data mining goals are to determine which variables have the highest correlation with stroke. Our project is high risk and high reward because it has the potential to save lives. Our null hypothesis assumes that there is a relationship between age, high glucose level, and stroke. The shape of our data set is 5,110 rows by 12 columns. There are 12 variables that we will use as predictors for stroke. We have both nominal and categorical data within the data set. Under attribute information, it is noted under smoking status that there are values marked as unknown due to the information not being available. There are potential null values, which we will address as the first step of our data mining project. We notice that there are 201 missing values for BMI and potential outliers as shown in the box plots below. For the data visualizations, I will pass the mic over to my teammate Rudy. And give you control.
Good afternoon, my name is Rudy. Thank you, Adila. Immediately here, these box plots, we can see that with age, we have two outliers. However, reviewing these outliers, they're input error. They're two float values, so we just decided to leave those. As far as average glucose level goes, however, there are a considerable amount of potential outliers as far as that goes. However, we decided to keep those because referencing Petru Lindsberg and Risto Royn with the article Hypoglycemia and Acute Strokes, that elevated glucose does injure the ischemic brain. So we decided to keep those. Now, moving on to BMI. Here's where we really had to take a look at BMI because, as Adila mentioned, there are 201 missing values, and there are unrealistic, outlandishly high BMI recordings that we can note at almost 100 BMI. So what we decided to do is to replace those values with the column mean. All right. And down below in figure 2, we have a visual verification of exactly that. We have no missing values listed at all. On to data understanding and the data exploration report. We noticed that with higher age, there's more prevalency for hypertension and elevated glucose levels. And we can see that with figure 3. We can see exactly that. The older our patients trend to be, they have elevated glucose levels as well as more prevalence to hypertension. Okay. Now, here is where we get to really break down each of these variables. Patients did not suffer from stroke. All right, so with figure 4, we get to really look into our target variable and the class imbalance that we're experiencing with these variables. We do have a little under 500 positively diagnosed stroke cases and almost 5,000 negatively diagnosed stroke cases. As far as gender goes, females are trending to be the majority, with male next, and we have one case of other, which we're going to leave as well, just because it's only one case. There's no risk of polluting the data. However, when we look at the positively diagnosed cases, we do see that's pretty shot down the middle as far as who suffered from stroke and who didn't. It's pretty even. Moving down, we have we have more stacked bar plots here. Here is where we're going to look at some pre-existing conditions. We experience the same class imbalance as we can see. However, when we focus more on the positively diagnosed cases, we do see that a good portion of those cases, these patients did have pre-existing conditions such as hypertension and heart disease. Figure 6. Figure 6, I believe, is one of the more interesting insights that we can get, just because if we look at the bar to the left, we notice that the vast majority of the patients are former smokers or current smokers, followed by never smoked and also unknown. Now, we decided to keep the unknown feature just because it takes up, the sample size is pretty considerable. So to avoid polluting the data, we decided to keep that. However, when we look at the positively diagnosed cases of stroke, we get to see that it's kind of hard to really identify that, but you do see that you have former smokers and you have current smokers that take up, it looks like, a good half of that bar, followed by never smoking. So that's another insight. Former smokers or current smokers do trend to experience stroke. And now I'm going to pass the next section to my colleague, Sai.
Hi. We split our data set into a test and training data set for logistic regression modeling. The training data set is 75%, and then test data set is 25%. We choose the age and glucose level as our main predictor variable. When we ran the logistic regression, the p-value for both age and average glucose level were less than 0.5. So it is very significant. Therefore, we failed to reject our null hypothesis. Both variables are strong predictor of stroke. The accuracy of our model in predicting stroke is 95%, which indicates that the model performed well, giving that our AUC is closer to 1 than to 0.5 at 85%. Then we have a balanced classification model. You can see in the figure 7. Our stroke prediction model based on age and glucose level is y equal to intercept negative 7.36 and coefficient for age is 0.066 and coefficient for glucose level is 0.00523. If we put the age at 68 and glucose levels 270, we will get a negative 1.45. Then we apply that negative 1.45 to logistic transformation, and we get 19%. If age is 68 and glucose level is 270, there is a 19% chance of having a stroke. If age increased from 68 to 75 and glucose level is kept constant at 270, there is a 27% chance of having a stroke. We can see that the age increased and then the chance of having a stroke increased. By increasing number of age to 7 from 68 to 75, chance of having a stroke is increased by 6% from 19% to 27%. We can see in the table 1 probability of having a stroke as the age increased, Y kept the glucose level constant at 270, the probability of having a stroke increased. Now I'm going to pass the conclusion to Adela.
Thank you, Sai. So we did find 2 articles that confirmed our findings in our project. An article from the CDC suggests that high blood pressure is common in people with diabetes, and high blood pressure is the leading cause of stroke. Additionally, the article Hyperglycemia in Acute Stroke states that high blood sugar is common in the early stages of stroke. A plausible next step for our project would be to create a healthcare dashboard for hospitals. This platform can be created by using Tableau to link to the hospital database to create visualizations.